Let's start with supervised learning, arguably the bigger and more important branch of machine learning. There are broadly two subcategories. In regression, we want to predict a continuous numeric target variable for a given input variable. Using the example from before, it could be predicting the price of a house given any number of features of a house and determining their relationship to the final price of the house. We might, for example, find out that square footage is directly proportional to the price, linear dependence, but that the age of the house has no influence on the price of the house. In classification, we try to assign a discrete categorical label, also called a class, to a data point. For example, we may want to assign the label spam or no spam to an email based on its content, sender, and so on. But we could also have more than two classes, for example, junk, primary social promotions and updates, as Gmail does by default. Now let's dive into the actual algorithms, starting with the mother of all machine learning algorithms, linear regression. In general, supervised learning algorithms try to determine the relationship between two variables. We try to find the function that maps one to the other. Linear regression, in its simplest form, is trying to determine a linear relationship between two variables, namely the input and the output. We want to fit a linear equation to the data by minimizing the sum of squares of the distances between data points and the regression line. This simply minimizes the average distance of the real data to our predictive model, in this case the regression line, and should therefore minimize prediction errors for new data points. A simple example of a linear relationship might be the height and shoe size of a person, where the regression fit might tell us that for every 1 unit of shoe size increase, the person will be on average 2 inches taller. You can make your model more complex and fit multidimensional data to an output variable. In the example of the shoe size, you might, for example, want to include the gender, age, and ethnicity of the person to get an even better model. Many of the very fancy machine learning algorithms, including neural networks, are just extensions of this very simple idea, as I will show you later in the video. Logistic regression is a variant of linear regression and probably the most basic classification algorithm. Instead of fitting a line to two numerical variables with a presumably linear relationship, you now try to predict a categorical output variable using categorical or numerical input variables. Let's look at an example. We now want to predict one of two classes, for example, the gender of a person based on height and weight. So a linear regression wouldn't make much sense anymore. Instead of fitting a line to the data, we now fit a so-called sigmoid function to the data, which looks like this. The equation will now not tell us about a linear relationship between two variables, but will now conveniently tell us the probability of a data point falling into a certain class given the value of the input variable. So for example, the likelihood of an adult person with a height of 180 centimeters being a man would be 80%. This is completely